Chapter 3, Domain Controllers in FSMO Roles. Introduction. Welcome back. In this chapter, we're going to explore one of the most important topics in Active Directory administration, domain controllers and FSMO roles. Every Active Directory environment depends on domain controllers to authenticate users, store directory information, and provide essential services across the network. Most administrators understand that domain controllers are important. However, many don't fully understand the 5 special operations master roles that coordinate critical functions throughout Active Directory. These roles are known as FSMO roles, which stands for Flexible Single Master Operations. Understanding these roles is essential because when one becomes unavailable, the symptoms can be confusing and difficult to troubleshoot. By the end of this chapter, you'll understand the different types of domain controllers, the purpose of each FSMO role, recommended role placement strategies, and the correct procedures for transferring or seizing FSMO roles during emergencies. Let's begin with the different types of domain controllers available in modern Active Directory environments. Section 1. Document Controller Deployment Types. Not all domain controllers are identical. Depending on business requirements, Microsoft provides several deployment options. The most common type is the read-write domain controller, often called an RWDC. This is the traditional domain controller found in most environments. It stores a complete, writable copy of the Active Directory database and can process changes made by administrators. Whenever a user account is created, a password is reset, or a group membership is modified, a read-write domain controller can accept and replicate those changes. Another option is the read-only domain controller, commonly known as an RODC. Introduced in Windows Server 2008, the RODC was designed primarily for branch office deployments. An RODC maintains a copy of Active Directory but cannot accept direct modifications. By default, user passwords are not stored on the server. This significantly reduces security risks. If the server is physically stolen or compromised, attackers cannot easily extract domain credentials. Organizations commonly deploy RODCs in remote offices where physical security controls may not be as strong as those found in a central data center. Microsoft also supports virtualized domain controllers. Beginning with Windows Server 2012, domain controller cloning became available. This feature allows administrators to create new domain controllers rapidly within virtual environments. The cloned domain controller automatically generates a unique identity and integrates safely into the Active Directory environment. This capability simplifies scaling and disaster recovery operations. In hybrid environments, domain controllers can also be deployed in Microsoft Azure virtual machines. These Azure-based domain controllers provide local authentication services for cloud-hosted workloads and users. Instead of sending every authentication request back to an on-premises data center, Azure resources can communicate with a nearby domain controller, reducing latency and improving performance. Regardless of deployment type, all domain controllers participate in replication and contribute to the health of the directory. However, some operations require special handling. That's where FSMO roles enter the picture. Section 2. Understanding the 5 FSMO roles. Active Directory uses a multi-master model. This means most domain controllers can process updates independently. However, certain operations cannot safely occur on multiple servers at the same time. To prevent conflicts, Microsoft created 5 specialized FSMO roles. These roles are divided into 2 categories: forest-wide roles and domain-wide roles. The first forest-wide role is the Schema Master. The Schema Master is responsible for processing all modifications to the Active Directory schema. The schema defines every object type and attribute that can exist within the directory. Whenever an organization extends the schema, perhaps during an Exchange deployment or a major application installation, those changes must be processed by the Schema Master. Because schema changes replicate throughout the entire forest and are often difficult to reverse, careful planning is essential. The second forest-wide role is the domain naming master. This role controls the addition and removal of domains within the forest. Whenever a new child domain is created or an existing domain is removed, the domain naming master validates and coordinates the operation. Without this role, administrators cannot modify the forest's domain structure. Microsoft generally recommends hosting the domain naming master on a global catalog server for improved functionality. The first domain-wide FSMO role is the PDC emulator. Of all 5 FSMO roles, this is generally considered the most critical. The PDC emulator performs several important functions simultaneously. First, it serves as the authoritative time source for the domain. Kerberos authentication relies heavily on accurate time synchronization. If clocks drift too far apart, authentication failures occur. Second, the PDC emulator processes password changes and quickly distributes those changes throughout the environment. This prevents situations where users reset a password but cannot immediately log in because replication has not yet completed. Third, the PDC emulator handles account lockout processing. It is also heavily involved in group policy management and compatibility with legacy systems. Because of its importance, administrators should place the PDC emulator on a highly available and well-resourced domain controller. The second domain-wide role is the RID master. Every security principal in Active Directory receives a security identifier, or SID. The unique portion of that SID is called the relative identifier, or RID. To prevent duplicate SIDs from being created, the RID master allocates RID pools to domain controllers. Each domain controller receives a block of available identifiers that it can assign to new users, groups, and computers. When the pool begins to run low, the domain controller requests another allocation from the RID master. If the RID master remains unavailable for an extended period, domain controllers eventually run out of available identifiers and become unable to create new objects. The final domain-wide role is the infrastructure master. This role maintains references to objects located in other domains. These references are commonly called phantom objects. In multi-domain forests, this role ensures that cross-domain object references remain accurate and up-to-date. There is one important design consideration. The infrastructure master should generally not be placed on a global catalog server unless every domain controller in the domain is also a global catalog server. Failing to follow this recommendation can prevent phantom object updates from occurring correctly. Section 3. FSMO Role Placement Best Practices. Now let's discuss placement strategies. In smaller environments with only 2 domain controllers, administration is relatively straightforward. A common design places the PDC emulator, RID master, and infrastructure master on one domain controller. The schema master and domain naming master are placed on the second domain controller. Both servers are configured as global catalog servers to maximize availability. In larger environments, role placement becomes more strategic. The PDC emulator often receives its own dedicated domain controller because of its workload and importance. Organizations may distribute the remaining FSMO roles across multiple servers to improve resilience and reduce dependencies. For multi-domain forests, special attention should be given to infrastructure master placement to ensure proper phantom object maintenance. Regardless of size, administrators should document FSMO role ownership and periodically verify role placement using PowerShell or administrative tools. Knowing where each role resides becomes extremely important during troubleshooting and disaster recovery situations. Section 3. FSMO Role Placement Best Practices, 7:30 to 9:30. Now that we understand the purpose of each FSMO role, let's discuss placement strategies. In small environments containing only 2 domain controllers, role placement is relatively straightforward. A common approach places the PDC emulator, RID master, and infrastructure master on one domain controller. The schema master and domain naming master are placed on the second domain controller. Both servers are typically configured as global catalog servers to maximize availability. Larger environments require more planning. Because the PDC emulator performs several critical functions, many organizations dedicate a high-performance domain controller specifically to that role. The remaining FSMO roles may be distributed across additional servers to improve resilience and reduce dependencies. In multi-domain forests, administrators must pay particular attention to infrastructure master placement. Proper planning helps prevent replication inconsistencies and cross-domain reference issues. Regardless of environment size, administrators should regularly document FSMO role ownership and periodically verify role placement using PowerShell commands or graphical administration tools. Knowing exactly where FSMO roles reside becomes critical during troubleshooting and disaster recovery situations. Section 4, Transfer versus Seizure, 9:30 to 11:15. Eventually, administrators may need to move FSMO roles between domain controllers. There are two methods available: transfer and seizure. A transfer is a planned administrative operation. The existing role holder remains online and healthy throughout the process. Administrators commonly perform transfers during hardware refresh projects, server migrations, operating system upgrades, or data center moves. Microsoft provides several supported methods for transferring roles. Administrators can use graphical management consoles or PowerShell commands such as move-AD directory server operation master role. Transfers are safe, controlled, and fully supported. A seizure is very different. Seizure is reserved for emergency situations when the current role holder is permanently unavailable. Examples include catastrophic hardware failure, severe operating system corruption, unrecoverable database damage, or complete data center loss. In these scenarios, waiting for the original server to return is not practical. Administrators use the NTDSUTIL utility to forcibly assign ownership of the FSMO role to another domain controller. However, there is a critical rule every administrator must remember. Once a role has been seized, the original domain controller must never be brought back online. Doing so creates conflicting ownership information and can cause serious directory inconsistencies. The failed server should be rebuilt, properly removed from Active Directory, and replaced with a clean installation. Because seizure is an emergency operation, it should only be performed when recovery of the original role holder is impossible. Chapter Summary, 11:15 to 12. Let's review the key concepts from this chapter. Domain controllers can be deployed as read-write domain controllers, read-only domain controllers, virtualized domain controllers, or Azure-hosted domain controllers. Active Directory relies on 5 FSMO roles to manage operations that cannot safely occur in a multi-master environment. The Schema Master and Domain Naming Master operate at the forest level. The PDC Emulator, RID Master, and Infrastructure Master operate at the domain level. Proper role placement improves availability, performance, and administrative efficiency. Transfers are planned operations, while seizures are emergency recovery procedures. Most importantly, the PDC emulator remains one of the most critical components in any Active Directory environment and should be monitored carefully. In the next chapter, we'll explore Active Directory objects, including users, groups, computers, and the attribute model that defines them all. See you in Chapter 4.